And moving on, the prize for engineering. The HANA project began back in 1992. At the time, Korea's semiconductor industry was just rising, and I thought maybe I should do research on software technology related to the semiconductor industry. Before HANA, the enterprise database is huge, and hard disks were used as the main storage of large-scale enterprise database, and you would extract the data and load it on memory for the CPU to be able to process it. So because of this, real-time data processing or analyzing large quantities of data on a real-time basis was unthinkable. The concept of HANA changed the whole paradigm. If the database could fit into a DRAM memory, and since the data is sitting on the memory, the CPU will be able to access the data faster. So the speed is tens of thousands times faster, and for application software, the speed could be 1 million times faster. We made the first generation system in the lab, but I wasn't satisfied. So to make the second generation system, I started my own company in 2000, and it started from there. I went to Silicon Valley, where I met many companies and customers and investors, and ideas kept evolving. So what is so innovative about HANA is that there is this gap between the companies using the existing technology and the ones using this new one. The latter are way more competitive. I believe innovation is possible through challenging experiments and tests. And even if you fail, you should never give up. And you keep going and you enable innovation. Frankly, it is difficult to go down a path that no one has gone before. I would like to ask Mr. and Mrs. Kyun Cha to come forward. Congratulations, we will hear from Professor Cha. Dreams do come true, but through trial and error and after many failures. This is what I want to share with you at the outset. It feels like a dream that 30 years ago I began research on in-memory database system software as a professor at Seoul National University. That was when the Korean DRAM industry was just taking off. Returning from Stanford, where I'd studied under the government scholarship program, I was looking for a new research topic that could leverage the Korean industry, and I thought of replacing external storage like hard disks or SSDs, and instead using DRAM, main memory, to store the data and enable fast processing via in-memory database system software. I did not have any relevant experience in the field back then. At the time, a computer's memory size was in megabytes. But I embarked on the research, knowing that the memory size will grow million times and tens of millions of times. I spent several years developing the first version of the software with my students. There were not visible results, but we never gave up and we kept working in the lab. Then, innovative ideas that no one has thought of began to emerge. In 2001, three papers published in IEEE, ACM, and VLDB received praise from the reviewers. And I dared dream of a world where we could change the database market dominated by the big players, the likes of Oracle, Microsoft, and IBM. I knew in order to realize the dream, working in a university lab was not enough. I went to Stanford as a visiting professor to explore the possibility of starting a company in Silicon Valley. In a seminar class that I taught back then, Professor Jeff Ullman, a recipient of last year's Turing Prize, suggested that I don't need to just rely on government grant. I could start a company and get investment from VCs and engage in research with more impact. And when I heard that, I was quite surprised because few US professors started their own companies at the time, and I was very much encouraged. But the novice businessman soon met with trouble because the dot-com bubble burst and because of the 9/11, the Silicon Valley froze up. But fortunately for me, I weathered the storm for 2 to 3 years. I continued to do my research, and all competition was gone. In 2005, when I was discussing investment with the VC company Kleiner Perkins, a global software company, SAP, made an aggressive M&A offer. After we signed an M&A deal with SAP in secret, we continued our experiments backed by the company's asset and financial support. In October 2008, when the platform model, to be named HANA afterwards, was disclosed, the project was scaled up to a company-wide project. At the end of 2009, at a conference held in Germany, San Francisco, Silicon Valley, Seoul, at 2 a.m., the 1 terabyte memory sample provided by Samsung Electronics was shown to Hasso Plattner, the founder of SAP. And he shouted, "This is a game changer. Now our time has come." Since then, the HANA team has grown to include 2,000 people, and our team successfully changed the market paradigm. Many companies around the world are using HANA in their real-time businesses. I would like to thank my students, colleagues at Seoul National University, and also the colleagues at SAP for being with me down the unknown path. When I started my long journey in Silicon Valley, there was Professor Seung-jin Hwang of Stanford Graduate School of Business who encouraged me. Thank you for encouraging me and showing me the way for 20 years. Thank you, Mr. In-shik Lee, founding partner of Vertex Ventures. They have come all the way here from the US to congratulate me in person. My biggest thanks go to my family, with whom I haven't been able to spend much time under the excuse of being too busy. My wife, my children, my mother, my parents-in-law. Thank you for coming here tonight. Dreams do come true. I experienced firsthand how a handful of determined people could change the world. To nurture future talents, I embarked on my next venture, which is establishing the great Graduate School of Data Science at SNU. Attending the ceremony is the Dean of College of Humanities at SNU, Professor Seok-jae Lee. He and I spend a lot of time thinking about what the future education should look like. We'll make sure that the Hoam Prize money is put to good use in fostering creative talents. Thank you.